Okay. So yesterday we took this data set. Okay. Now let's see if you're able to access the data set today also or not. Okay. Otherwise, the whole effort will go waste. Let's see. So we took this data set, we divided into X and Y. Okay. And all our work will be on X, isn't it? So that's why, yeah, it has read the data. So that's why we have to break it into X and Y. Then yesterday we did replacing the missing values with the mean, right? And we used simple imputer from sklearn. Hope you have installed sklearn successfully, because this is the main or this is the one, okay, library that we're going to use for all our future work as well. Okay. Next, we'll move to handling categorical data, right? Okay. So what is the first step that we do? We discussed about 3 steps yesterday, right? For categorical data. What is the first step?
Encoding.
Encoding, right? We said label encoding, correct. Label encoding. So we need to encode the label. Okay, let's see this. So to use label encoder, we need to call label encoder from sklearn dot preprocessing import label encoder. Okay, this is label encoder. So now we'll do LC for label encoder, so object for label encoder, and I will call label encoder. Okay, so this is your constructor. Init function is called label encoder. Now we have to tell which column we want to encode. So this is X first column, isn't it? So X all rows, comma, first column, correct? Equal to, okay, LC label encoder dot fit transform. Okay, fit transform, and what's the y, what's the value? Same. Okay, so we will transform x0, first column of X, will transform and we will save it as first column itself. Okay, so what happens? The first value goes away. Okay, the text will go away. Okay, so now if I told you right yesterday, we do fit and transform every time. Okay, so fit transform together we have done, and you should be able to see this value now. So if I say print X here, okay, let me comment this X. Okay, so that we just get this last one. So see, this had been encoded. So I told you it will encode based on the text, alphabetical order. So east became 0. This is probably north is 1, south is 2, and your west is 3. Okay, so this text got now encoded as number. Okay, which is good, but we shouldn't stop here, right? We need to now do what? Column transform. We need to do column transfer. So column transform is in sklearn.compose import column transformer. Okay, so we'll use column transformer to transform the column. Okay, and there are some parameters that we need to pass. We will see one by one. So let's do it here. So I'm going to create an object called transform equal to, okay, now I'm going to say column transformer. Okay, now column transformer takes multiple parameters. Okay, takes multiple parameter. So, and we pass this parameter in terms of list here, and then so we'll pass it. Okay, but after this we have to say remainder. Remainder means, okay, what should we do to rest of the values? Okay, so we say pass through. Okay. So see, which column, see, we have to pass which column, right? So which column should we do the column transformer? That will come here. Okay, column 0 we have to mention, because column 0 is what we need to transform. What happens to the rest of the column? What happens to the rest of the column?
They will
They should
remain
pass
the
through,
same.
remain the
Yes.
same. That's why we say pass through. Okay. Remainder is to indicate what should columns that are not transformed be. So we are saying it, let them be as it is. Okay. As it is. This is called pass through. Okay. Okay. Now, what should we do to the column here? Okay. So here we have to give set of values as a, okay, so it accepts one values and we have couple of things to talk about. Okay, so we are giving all of them as a tuple. Okay. Okay. Now, how do you want, okay, this data to be? Okay, so we want this data to be encoded as 0 to 3 columns. That process is called one hot encoder. Okay, and that is also part of your pre-processing. So here we'll say one hot encoder. Okay, and we have to pass the value here. Okay, so first thing is the parameter itself. So we'll say here one hot encoder, then the we have to call the object here one hot encoder. Okay, and then which column you want to transform? Which column we need to transform? Column 0, right?
Yeah, column 0.
If you have
0.
multiple columns, first column, right? And if you have multiple columns, you can give multiple, like 0, 4, 6. Okay, so if there are, if you have multiple, like, in this example we have only one column which has a canonical value, right? But you can have multiple columns as canonical value, so you can mention which all columns you want to transform. So you're saying whatever is within this list you transform, and whatever is not in this list you leave it like that. Okay, so this is how you do transform. Now you want to see the output of X. Okay. Okay. So this is ready, because what you have to do now is you have to transform, right? You have to fit and transform, isn't it? This is to define that this is what we want to do. We created that object transform. Now we have to apply this. Correct?
Yeah.
Now we have to apply this.
So we.
Sorry, what happened?
No, I'm good.
Okay. Okay, good. So now we have to apply it, right? So we say X equal to, okay, transform dot fit transform. Now we are applying this on X. Okay, so fit transform X. Okay, so fit transform X. Now you also have to transform Y here, isn't it? Because Y also has text data, right? So we have to apply on y. But since the process is same, so we can ignore it. But if you want to apply on y, same thing you can say y equal to y equal to no, but before that you have to do label encoder, right?
Yeah.
We haven't done label encoder, right? Yes. So you can say here label encoder dot fit transform y. Okay. And then you can, but see, in this case, we have win or loss, right? So win or
Yeah.
loss, we don't have to do
Column.
transform
Column
because
also.
column transform because it only has two values, right? 0 and 1. And 0, 1 will remain as 0 and 1 only, is it not? But yes, if at multiple values, okay. But even with multiple values, okay, we should not do column transform on y because y is what we are going to predict 0, 1, 2, 3, correct? So your y will not have okay, because y is one value, right? We are going to predict only one value, right? So that's why there's no way you can predict two values, right? So that's why we don't perform column transform on
Column.
y, right? But we have to encode it because our mathematics will not going to give us the text. It's only going to give us 0, 1, 2, 3. So we are performing column transform, encoding, but not column transform. Okay. Now the problem here is that this x we'll have to convert into array. Okay. Let's see. So now you see this. Okay, 0, 1, 2, 3, 4. I mean 0, 1, 2, 3. So 4 columns have been added, right? And
Yeah.
what did we discuss? That we have to delete one column, right?
Yes.
Right? So what I can say here, x is all of these. I can delete anyone, right? So I can say x equal to, okay, x equal to x of all rows and from 1 to 0 columns, right? Now when I run it, you see, first column is gone. So our data is now ready for
Analysis.
right to get into. Okay, we don't have any outliers, but outliers you can use the method that we discussed in analytics. Okay, when we come
Remove
across,
one.
yeah, we can remove the
Okay.
outliers. But x is
Yes.
not ready. Okay, the next step is to break it into train, test, and test set, right? So here also we have something called as model selection in scalar dot model selection and import train test split. This train test split will help us to okay to split it, right? Now when you split it, we are going to get 4 set of values. Okay, you are going to get, see, we are giving x and y, right? So x will be broken down to x train and y x train and x test. Y will be broken down to y train and y test. And I've already told you why we use this model, right? We are using train and test to perform training and test, right? Basically, we want to train, okay, and then test it later, which anyway we'll not do it now. When we get into models, we'll do that, but we have to break into training and test, right? So call this train test split, and this is going to give us first x train, then it will give us x test. Now you'll get y train, you get y test. So in the model, we have to pass x train and x train and y train to the model, saying this is the input data and this is the output data, right? X train and y train we pass to the model, and the output that model gets, okay, model will learn it, okay. Then you will pass only x test, saying that model, now that you have learned, here is X text, give me the value. So you get something for a predicted value. That predicted value you compare with Y train to know how well the model has done it. Okay, very simple step, isn't it? Training, test, split. Okay, now you pass X, you pass Y, and you give the test size. Okay, 0.2 for 20%, 0.3 for 30%, 0.25 for 25%, right? It's up to you what you give, but generally we give 20 to 30%, right? So you can give 20 to 30%. Okay, so this is your X, okay, function. This is how you split X and Y. Once you have splitted X and Y, you can print them. You can print X train, okay. You want Y train, so Y train, then X test, right? And then you want to say Y test. What happened? Why Y test is not coming? Oh, X train, this is Y test, right? X train, X test, Y train, Y test. I give train twice. Okay. Now you see, these are your X train, okay, followed by, are these? Yes, right? This is where the bracket ends, correct? This is your X train, and these are equivalent Y train here. So one is output of this. This is giving output of 1. This is giving output 0. This is giving output 0. Fourth one is giving output 1, etc. Right? And then this is your X test.
Yes.
Okay. So it has taken how many? 3. It has taken 3 rows as train. And these are your testing values, Y. So this is the 0 output of this, 0 for this, and 0 for this.
So that test size is for the how much of data we want to retain for test data, right? 20% data is that
Generally,
right?
20 to 30%. Yeah.
Okay.
That's the thumb rule. Yeah. Okay. And we'll discuss more, like, sometimes we have to deal with unbalanced it. So when we are done with model, then we'll take some examples. Okay. We'll talk about few examples. Then we'll see that sometimes, you have to balance the data and things like that. But in general, okay, normal circumstances, we take 20 to 30%. There's some exceptions, of course, right? So we'll talk about those exceptions once we are done. Okay. We'll take some examples and then we'll take exceptions.
Okay.
All right. So this is how we have done test and test and train. Okay, train and test. We have broken down to train and test. Next is what? Feature scaling, isn't it? We still have to do feature scaling, the last part. So now from here you have sklearn dot pre-processing, and we will use a standard scaler. Standard scaler will convert this data set into your Z scaling. Okay, this is your Z scaling. Okay, so very simple. Okay, so I'm going to say standard scalar equal to standard scalar object is created. Okay, now I need to fit and transform X train. Okay, so what I'll do here, I'm going to say, okay, you can replace the old value, or you can say X train underscore SC, or you can replace the old value itself. Anyway, okay, it's better to replace old values because we are not going to do what? We are not going to reuse, right? We are anyway going to use the same value. So let's replace it. So X train equal to SC dot fit transform. And this is train, so we will pass X train. Okay, you want to similarly we can pass X test, right? So we are doing it separately because we do not want, algorithm to even have a guess that what we are going to use in test. Okay, now if you print again, so instead of that, I'm printing it here. Now you'll see you had 40 and that big numbers, right? Now let's see this. This has been transformed now. It has actually transformed even these zeros and one. Okay, so so this has transformed even zeros and one. Okay, but you do not want to transform zeros and one. So you can remove, right? You can say last two or right, third and fourth. Okay, you can do that. Generally, we don't transform the zeros and one. That is the column values. But this is how you can do transform using standard scalar. You can do scaling. Okay, using standard scaling. All good? So this is what we do in pre-processing. After pre-processing, okay, our data is now ready for getting into model
Next level.
building.
Yes.
Next step, yes. Okay, but before we do that, I also want to talk about one more concept here. Okay, there's also a concept of K cross validation. K fold, okay, K fold cross validation. Okay, what is this technique? Okay, now you see when you create a test and train, okay, and you test it, right? It's like this, okay. Simple way to compare this with, again, what we were talking about yesterday was that example of student, right? In the class, right? Do we have only one test? No, right? We have multiple tests, right? Quarterly, half yearly, final, test 1, test 2, right? Unit test 1. Why do we have multiple tests?
To check the progress at a
Check the
given point.
check the progress, and also to make sure that it's let's say you fall sick for one test, you don't miss it, right? If there's only one test, and both ways, right? If you're sick and you are not able to prepare well, you got low marks, which you probably don't deserve it, right? And just because you the you studied and those questions only came in that exam, right? Even to avoid that kind of scenario, you got very high marks because you studied those topics. But if you are writing 4-5 tests, the chances are that that kind of situation will not occur. So in a way, you are trying to do the balance out act, right? Okay, you do not want either, okay, a student who is deserving to get good marks to get bad marks just because that student was not ready for that exam, or who is not deserving got very high marks because of whatever reason. Okay, so same thing can happen, that when you divide into train and test, it can happen that kind of test that you have selected, your model is probably not performing well. Okay, because see, you divide train and test, right? Now you divide train and test, data got divided, okay, and you go ahead and you get accuracy of, let's say, very low accuracy, or otherwise also with the kind of data set that you got, it was giving you very high accuracy, which is which probably is not the nature of that model for that set of data set. So you do not want to end up either having very low result or very high. So what you do is you kind of run multiple times. So K here indicates how many times you want to run the same algorithm. Okay. So K fold will create K different sets of training set and test set. So K fold algorithm will create K different set. And when you are doing the model, you will run the model on these K different sets. Okay. Did you understand what I said? Okay. So yeah. So that's why we perform K, that we do not want, biasness to enter into the system. We're trying to divide the biasness. So what it does is it creates, like when you say K, it will create 5. If you say 5 row, okay, when I say K equal to 5, so it creates 5 different sets. Okay, so if you have 10 rows, it'll create 2 rows, 10 sets. If you have 100, it'll create 20, right? 5 sets. And it will take first 4 as training and last one as test. In next time, first one will be taken as test and next 4 will be taken as training. You understand what I'm saying? So wait, let me go to Paint and then we'll talk about it. So let's say, you have 1,000 rows. Okay. So it is dividing these rows into 5 parts. So you have 1 part, 2 part, 3 part, 4 part, and 5 parts, 5th one. Okay. So you got 5 parts. So I can call it as 1, 2, 3, 4, and 5. So what it does is, in the first step, okay, let's say these 4 are taken as training and this is taken as test. Okay. Next time when you run, okay, it will take these 4 as training and this as test. Then it will take 3, 4, 5, and 1, right? So you have 1, 2, 3, 4, and 5th was test. Then you have 2, 3, 4, 5, and 1 as test. Then you have 3, 4, 5, 1, and 2 as test. Then you have 4, 5, 1, 2, 3 as test. Then 1, 2, 3, 4. Then 5, 1, 2, 3, 4. 1, 2, 3, 3, and 4th one as test. Okay. So you are jumbling up. Okay. So that, okay, and so that you get 5 different results and then you take average of this. Okay, to know how well the model has done. So we are not running the model only once, but as part of K-fold, we are running this model 5 times or K times rather. You decide what should be K value. Okay, so the train and so K-fold will only divide this train and set not just into one, but recursively it will do for 5 different sets. And then you run model in each of these K-fold. Okay, it's like folding the data into 5 parts, right? That's why it's called K-fold. Okay, you fold it into 5 parts. You take 4 as training and 1 as test. Again, 4, different set of 4. Okay, so this technique is called K-fold, and this K-fold is done to split the train test. Okay, it's a method of splitting the train. So okay, so it's a method of splitting the train and test. So it's not something that we do to the model. It is part of pre-processing itself, where you are playing with the data itself here. Okay, so this is the K-fold thing, and you can directly call this K-fold from the model selection. Okay, model selection has K-fold, and you simply have to say how many folds you want. Okay, and instead of doing the train test split, you will do the split based on the K-fold. Okay, so let me take you back to here. Okay, but before I talk about K-fold, okay, before I talk about K-fold, one more thing here. Okay, so this is X train, right? What is the value here? Okay, forget about these two will anyway remain same between zeros and 1. Look at this value here. What is this value? Minus 47, correct?
Yeah.
Minus 47. Let me run it again. What happens? Okay, again it is 47. Let me run it again. Okay, now what's the value?
2.12.
2.12, right? What happens is, okay, this K the split, okay, does random split. Okay, what is random split? You have 1 to 10, right? And if I say you have 10 and I said that 20% is training. So if I say 20% training, that means 80% is your 20% test, right? So 80% is your
Yes.
training data, right?
Training.
So 80% means 8 rows should be training and 2 rows should be test, correct? But
Yes.
which two rows we have not mentioned, isn't not? Which 2 rows should be test and which 8 should be training, we have not mentioned. So what it does, randomly it selects. Okay, randomly it will, sometimes it might select 1 to 8 as training, or it will select 2 to 3 to 10, or 1, 3, 5, then 6, 7, 8, 9, 10, right? Randomly, it will do randomly every time. Okay, and that is the right way also. You do not want, things to be, that's why, every time you run, you're getting different answer, so that model is not being biased towards the data set that you have provided. Okay, you can run it with multiple different combinations and see if the results are same. Okay, let's say if you run once and you get result as 80%, next time you run it, you're getting 82%, next time you run it 79%. That means data set is more or less correct. Okay, it's good data set because it's always giving you around 80% result. But one time you run, you get 90%, other time you're getting 70%. That means data set has some problem, isn't it? Okay, it cannot give you same model, same parameters, cannot give you such a high difference in the result. So that's why we have to, okay, use random technique, and random is the right way. Okay, every time you run it, it's going to take different set of, okay, training and test. Okay, so this train and test is doing, okay, whatever it can, in the sense it is also doing, it's also being random. Okay, but k-fold cross validation is a, again, is a actual technique of, handling these. Did you understand what I'm saying?
Yes.
Okay, very important. Okay, in terms of understanding, because these are your very candidates, very good candidates for interviews. Okay, these are what most of the things they'll ask you in the interview. Very good questions to confuse you in the interviews. Okay, so that's right. So how can you make sure that training and test split is done correctly, or without any bias? Introduce k-fold cross validation. Okay, so k-fold cross validation works in pre-processing step. Okay, and it helps us to create different number of trend test split. Okay, so how to do that? Let's see an example. So this also is in model selection. So I'm going to say from sklearn dot model selection import k-fold. Okay, this is called k-fold, and now we have to create a object, right? So I say kf equal to k-fold, and it takes parameters like how many splits you want to make, n splits. So here I'll say 3 splits. I want to make 3 splits. Okay, shuffle. Okay, so do you want to shuffle the data, okay, or not? I'll say no. Okay, or it's not compulsory, but by default it is false, so you can leave it like that. Okay, so now it's going to create 3 different sets. So 3 different sets of training and test set. Okay, now if you want to use it, you can say for okay, we'll apply on X train. Okay, so for train comma test, okay, in k-fold dot split. Okay, and here you pass the data. So you want to train on X, so you pass X here. Okay, now you see, you can actually see different combinations. So I'm going to say this print X train, no, what is that? Train only, right? We call train and test. Train comma /n test. Okay, now you run it. So for loop is there. Every for loop will give train and test, and you put a model inside the for loop. You are putting a model inside the for loop. Okay, if you put model inside the for loop, okay, your model, will run 5 times or whatever, k times automatically, right? So now you see here, I gave k equal to 3, right? It has created 3 folds here for us. This is first fold, this is second, and this is third. I give x, then why did it split? So these are the serial number, okay? These are the serial number. It's saying that row 0, 1, 2, 3, 4 is one set, and 5, 6, 7, 8, 9, 10, 11, 12, 13 is another set. So see, it has divided into 5 parts. 0, 1, 2, 3, 4 is 1, 6, 7, 8, 9 is 1, and 10, 11, 12, 13 is another. So first time, this first 5 is taken as test and rest as training. Now you see, if this is 1, this is 2, and this is 3, correct? This is first part, this is second part, and this is third part, right? So first part is test, and second and third part is training. Now here, second part has become test, first and third part is your training. Here, first and second part became training, and third part is your test. This is the row number. So k-fold will give you the row number. Okay, and when you run the model, it knows, okay, these rows now, row number, this is the index of the rows. These rows number I have to take as training, and these row number I have to take as test.
Okay.
Okay, so that's it. With that, we finish our first part, which is
Labeling and transforming.
we call it,
Model
yeah, pre-processing. All these two together, we call it as pre-processing. Okay, so we call it as pre-processing.
Okay.
All right. Now we will get down to our first model building, which is called as regression. Okay, regression. I'm just seeing, Jamit, I sent a message. No, my contact list has become so heavy. Okay, let me. Okay, so we're talking about our first model called regression algorithm. Okay, so the purpose of regression is, okay, how do you know that you have to perform regression? So I told you, right? Before you perform regression, you need to know that you have to perform regression. So how do you perform regression? When do you perform regression? So two conditions. Okay, and in fact, they might ask you what is regression, right? So a regression algorithm. Now see, the concept of regression has been in use for many years. It's in use for more than 100 years, and I'll tell you briefly about that as well. But before that, when to use regression, or what is regression? Regression is supervised algorithm. Okay, the first thing that you have to talk about when you talk about regression is supervised algorithm. That means you have past data. Okay, you have X train and X test. Okay, and why, when you say X train, it also means Y train, right? So you have X train, X, of course, if you have X train, you can create test. Test is subpart, subset of X test train only. Okay, so if they ask you what is regression or when to use regression, okay, the first thing that you have to talk about is it is supervised algorithm. Okay, supervised means you have X and Y value from past. X and Y values from the past data. Right? So I want to predict if I'm, my cousin's mark, right? So I have the cousin's senior's details with me. Okay, both X, like factors impacting marks, like how many hours you play, how many hours you watch TV, how many hours you study, how many hours you do swimming, etc., how many hours you do meditation, things like that. So those are your X data, and how much marks they have got, Y data. So you have both X and Y. Okay, that's why we say supervised algorithm. And second thing is, your objective is to predict predict a numeric value. Okay, your objective is to predict numeric value, and that's when we use regression algorithm, right? So regression algorithm is a supervised learning algorithm. Okay, it's a supervised learning where the objective is to find numeric outcome. Okay, so these are the two reasons. When you see, you should know that, okay, I have to use regression algorithm. Okay, now why it's called regression? Why not progression? Okay, why not progression? Okay, so the concept here, the regression concept is that, okay, you might have some exceptions, but still, you know, the result, end-to-end result is average value. Okay, and again, this comes from biology. Okay, and scientists have been doing this research for regression concept itself. Okay, it's not new. Okay, it's as I told you right just now, that it is more than 100 years old. It was developed in 1800 itself. So when these scientists were studying, you know, human behavior, human biology, and okay, that's when they realized that everything tends to be normal. Okay, now when you go for a checkup, medical checkup, okay, or you, let's say you have some some problem, and doctor gives you a medicine, right? Now all our body is not same, right? Okay, um uh, the structure inside is not exactly same, right, in terms of the power of the tablet, let's say. Okay, maybe I might need more power tablet. Generally, if you see, the kids medicine are different and adult medicine are different, isn't it? Kids
Yeah.
medicines are less powerful, adult medicines are more powerful. So even if you say compare, adult only also, okay, adults bodies are different, right? Not all bodies are the same. So even if you say 2 mg of medicine, it might mean that somebody might need 2.2 mg, somebody might need 1.9 mg only, correct? But what we have done, we have assumed that on average 2 mg is what we will need, right? So somebody who needs 1.8 probably is getting extra dose. Okay, might have some side effect. Some people who needs 2.2 is only getting 2, might take some longer time to recover. But most of the people will recover without any side effects in the shortest possible time, right? That's what it means, right? So that's why when you test some medicine, not everybody will give you same results. Some will give you faster, some will give slower. Somebody may not give results. Somebody might have some side effects also, right? So that's how body is. And in medicine, right? If you test a medicine in US and let's say it is perfectly suitable for US people, that medicine cannot be given to any other country. In the sense, you have to perform same test in India also, in every country. It's not that once you pass that test in one country, it is considered to be passed in all the countries. No. Yeah, because every climate, every country has a different climate. They have a different genetics, basically, right? So you have to test for all kinds of genetics, right? So it's not that if you test on any 10 people, then you can give it to 1,000 people. No, they'll ask you on what kind of races, what kind of people have you tested, right? Okay. So if you have tested in North Indian people, does not mean that, okay, your test site should have South Indian also. Your test site should have male and female both, right? So that's how you see the result. Okay, result is studies based on genetic pattern of body. Okay, not just human beings. So all the human beings will have it. Okay, so understand in raw form. Okay, let's say, okay, generally, okay, so let's take this example. You have Sachin Tendulkar, right? Greatest batsman, right? Sachin's son, do you expect him to be even more greater batsman than Sachin?
No,
Do you expect?
we can't. Yeah, we can't do.
No, but generally we expect that, right?
Oh yeah,
We say that, oh, if he's greater. Now, what science says exactly opposite. Okay, what science says exactly. So if you have become great, your son will become under this thing because God or nature, whatever you call it, has made everybody average. Okay. So if somebody does well, somebody will not do well, so that you become average. Okay. Very rarely, if you see in a cricket match, also if you see, or in a football match, you don't see 50 goals in a match, right? Because if somebody is playing well, other person will not play well, right? Like say if openers have hit centuries, maybe the third down, fourth down will get out sooner. Okay, because that's how the nature has maintained this world so far. Okay?
Balance.
Balanced. Okay, so example what they said is 1,000 years back, there would have been somebody with 6 feet height. Now we have these days we have 5 feet, 6 feet. You know, we have somebody who is more than 6.5 feet as well. So 1,000 years back, also somebody would have been 6 feet height.
Yeah.
Correct. Now, if you think of this as that, if you have 6 feet, you'll continue to have higher height. Then that person's kids would have been 6.1. Those persons' kids would have been 6.2. Right? So after 1,000 years, we might have somebody with 10 feet height also, right?
Yeah.
But it is not possible. Okay, that's why the word regression, not progression. Okay, we regress to average line. We regress to average line. Okay, that's what regression concept. Okay, that everybody is coming closer to average line. Now, average line is not average for everyone. Okay, average changes based on multiple factors, right? So if you take cricket only, if you take average score of openers, okay, most of the players around the world, every team will have scores somewhere around same. As you come down to 10th level, 10th player, okay, average will be much lower than the opener. Openers will have higher average of runs, and the 10th player will have lower average of runs. So you have multiple averages. One average for opener, one average for your lower ranked batsman, right? So yes, but then that's also average, right? That's also an average, okay? And all the 10th player will have similar averages. All the openers will have similar averages, okay? So where am I arriving at? So let's take an example here, okay? Let's take about this box here. Okay. Now assume you're talking about your prediction of marks for your cousin. Okay. So here you have y-axis. This is the marks that we want to predict. Okay. And this is x-axis. And because we can't represent 3-dimension or 4-dimension on screen, I'm assuming 2-dimension. And this x can be one factor, number of hours you study maybe, or let's say it's a combination of multiple factors. Okay. So that it's all combined to form one parameter. Okay. For simplicity, let's assume this is number of hours you study. Okay. Now, this is 0, right? 0, 0. Now, you have gone and you have asked your cousin senior. You ask them how many hours you studied and how much marks you got. And then you are plotting a scatter diagram, scatter plot. Okay. So you have done a scatter plot, something like this. Okay, this is the scatter plot. Now, what does the scatter plot say? Scatter plot says that this person has studied these many number of hours and has got this marks. Now, this person has studied more than this person and obviously got higher marks, right? But if you see this person and compare this one and this one, this has studied more number of hours but has got less marks than that, right? Which is possible. Not every day you're going to score centuries. If first match, if you score century, doesn't mean the second match also you'll score century, third match also century, right? Maybe first match you scored century, second match you will score duck out also. You'll be out on 0 as well, right? So this is how you look, okay? So this fellow has studied less number compared to this, but has got more marks than this, okay? But on average, what do you see? On average, you see that as you study more number of hours, you're getting more marks. We're not comparing one value, one row. We're not comparing one value. You have 1,000 values or hundreds of values, right? So your comparison is based on these 1,000 or based on these 100. With me?
Yeah.
Okay.
Yeah.
So what we see is your marks is based on average of multiple people on this XY axis,
Yeah, that's true. Mhm.
right? This is what we call as regression. So now regression concept says that you should draw a line, okay?
Mhm.
And line will have two things. One, the slope. Slope means the angle with respect to x-axis. Should it be at 0 degree or 90 degree or somewhere between 0 and 90 degree? And
Mhm.
second thing is the intercept. Okay. So let's
Okay.
say this is the line, okay, regression line. This is the regression line that we have drawn, which, okay. So which, how do you, so now there are multiple lines which are possible between this point, right? Any 2 points, there are infinite lines possible. But how do you
Yeah.
select the regression line? So line
Mhm.
that has minimum error. Okay, so now let's say if you have this line and let's draw another line, another regression line. Okay, so you have one line here and one line here. Now you measure the error. How do you measure the error? You measure the distance between line and the point here. So you're measuring the distance between line and point, all. And then you are measuring again with this rest line also. Measure,
Mhm.
okay. Whichever has less number of values, that is called regression line.
So,
Okay. Yeah.
which line has more points closer to it?
Don't say closer to it most, because if you see here, maybe the red line has more points closer to it, right? But this
Mhm.
line has less points closer to it. But if you add them all together, okay, so let's say this is 2 unit, this is 3 unit, 2 unit, 2 unit, 1 unit, 0 unit. So altogether, this has given you 10 units, okay, if you add them all together.
Mhm.
Here, if you see, this is 0, 0, 2, but this is 6,
Mhm.
right? This could be 8. So this has given you 18, let's say. Okay, 3 of them are 0, but the other 2 is giving you 8 and 8 and things like that, okay, higher values. So we will, this is a better fit than this. We saw fit, F-I-T, fit line, okay? This is a better fit than this red line.
So we add all these distances and take average.
Take average, yes.
I
And that
mean,
is called
mean,
as error, yes. That is called as error.
Okay.
Exactly.
So which one has less mean?
Error, okay. We
Okay.
say error,
Okay.
which one has the less error? And how do you measure error? Error is based on
The distance from the line to the point and
yeah,
the mean of all those values.
correct.
Okay. So these lines, like we need not start from 0, like we could.
It will not start from 0,
From
okay?
0. Okay.
Yeah, okay.
Okay.
Now, this is from the mathematical point of view, but if you again convert it into machine learning, okay, this is the error component, okay? If it starts from 0, then it becomes a straight multiplication, right? But, okay, rarely, okay, maybe 1 in 1 billion maybe start from 0, but it'll start from here somewhere. Okay. Now, if you go back to your 10th class or 11th class, you would have done this line. Okay. So we measure, okay, the slope of this line. And every line has equation mx plus c. Y has equation mx plus c. Okay. X is the x value, y is the outcome, and m and c is fixed for a line. M is difference in y by difference in x. And c is your this intercept. This is the c. This height is c and this slope is m. So if you take this line, okay, the slope of this line is fixed and c is also fixed. So m and c are fixed. So what this model, regression model, is doing is giving us this value for m and c. That's all. Okay. So I told you, right, regression algorithm is a family and you'll have multiple algorithms within this regression algorithm. So what each of these algorithms are trying to do is give us the best possible values for MNC. Who's giving us the best value for MNC? That's the competition between all regression algorithms. So regression algorithm is this. This is your simple regression algorithm, mx plus c. Okay. And the competition here between all the regression algorithm is to give us the best possible value for m and c.
Okay.
Okay. Once you know m and c, then for any value of x, you can predict y. Now, let's say if for your cousin's mark, m is 3, okay, and c is 20. That means, okay, if you study for 10 hours per week, you will get 10 into 3 plus 20, 50 marks. If you study for 15 hours, you will get 15 into 3, 45 plus 20, 65% marks. You can predict your cousin's mark, right? If you know the MNC value, you take your cousin's mark, you put it in this, and you get Y. Right?
Okay. Mhm.
That's what this regression algorithm is all about. Now, when we go to advanced algorithms, okay, it's not just about line, it can be any curve, any geometric curve.
Mm.
Okay, it can be a parabola, hyperbola, it can be a curve, it can be a circle, any geometric curve, okay, can help us based on the x value, okay. We can, we have to predict which curve. Basically, in regression, okay, we have predicted two things. One, which geometric curve best fits the data. So you have the past data, x data, okay, you will plot it, x and y, you will plot it. And with different algorithms, we are trying to find out different curve. For example, if you're talking about the first algorithm that we'll talk about is simple linear regression. In linear regression, we are talking about which straight line will fit the data. Then we'll talk about polynomial regression. In polynomial regression, which polynomial, hyperbola, cubic, which curve is it? So, which is better? Linear is better or polynomial is better? So, if straight line is fitting better than parabola, then we say linear algorithm is better than the parabola. If polynomial is doing fitting better than linear, we say parabolic is better. Then we get into SVM. SVM uses different curve. Okay, different shape of the curve. So each algorithm is giving us different shape. Now let's say, okay, we'll take here this, okay. Now data are something like this. Okay, this is your x. Now in this case, obviously linear line is not going to fit it better. None of this line will fit better. You need a parabolic equation to fit this, right? So in this case, parabola has a better output than a straight line. So with different algorithm, we are trying, talk about machine learning, okay? Deep learning works differently. We'll talk about deep learning later, okay? What we're going to do for now is about machine learning. So deep learning, machine learning, there is some difference, okay? So first we'll focus on deep machine learning algorithms, then we'll go down to deep learning. So in machine learning, we are trying to find which curve suits the output or your training data. Which curve suits the training data. All right.
Yeah.
That's the objective of
Machine learning.
yeah. All right. So we'll stop here today. Tomorrow we'll meet and we'll talk about simple linear regression. We'll take the same concept and we'll move ahead. Is that okay?
Yeah.
Yes.
Okay. Yes. Okay. So yeah.
So
Any
this
question?
example